Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So we've got lots of questions to answer from yesterday's section 11.4, and then we will get into 11.5 part 1 later on. So let's get started with questions. This is from section 11.4, problem number 17. Okay, and the question says, write the exponential equation as a logarithmic equation. And the equation is 14 to the negative 2.4 power equals the quantity n plus 9. Well, in this case, 14 is the base. So we're going to have log base 14 of n plus 9 equals negative 2.4. Now, the student had asked about this question. This is the answer they put in, and it was marked wrong. What's wrong with it is this. This whole thing is the quantity you're going to be taking the log of. So here you need parentheses. Otherwise, it thinks you want the log base 14 of n plus 9. So you've got to have that set of parentheses to draw that in. Okay, other than that, the answer you had was just fine. Now we're going to take a look at problem number 24. And it says solve for x. We have log base 27 of 9 equals x. So the first thing we're going to do is put this into, I'm going to move this over here, into exponential form. So the base is 27, so it will become 27 to the x power equals 9. We talked yesterday about how if you had 2 bases that were the same, then the exponents would be the same if it was in an equation. Likewise, if the exponents are the same, the base can be the same. We'll get to that. So what I could do here, I could take 27 and write it as 3 cubed. And I could take 9 and write it as 3 squared. Why would I want to do that? Well, then the next step I can do, a power raised to a power, you would multiply the exponents. So this becomes 3 to the 3x equals 3 squared. Now, since the bases are the same, the exponents are the same, which leads us to this. 3x equals 2 and x equals 2/3. Any questions about that problem before we go on? All right, let's take a look at problem number 27. It again says solve for x, and we have log base x of 1/27 equals negative 3. So taking this logarithmic equation and putting it in exponential form, we get x to the negative 3 equals 1/27. Well, here we're going to have, the base is the thing we have to solve for. So if we could get the exponents equal on both sides of the equal sign, then the base would be equal. Well, 1/27 is 1/3 cubed. We don't ordinarily take a term or an expression that has a positive exponent and rewrite it with a negative exponent. But in this case, we're going to do that because we want to match this. So now what I can do is I can take the right side and make this 3 to the negative 3 power. Okay, well, x to the negative 3 equals 3 to the negative 3, therefore x equals 3. Any questions about that one? Okay, going on. Here's number 41. It says If P dollars is invested at the end of each year in an annuity earning annual interest at a rate of R, the amount in the account will be A dollars after N years where, and then it gives this big long equation. You know what? I'm going to show this formula because it's so long. So we're looking at this whole thing here. Okay, so we've got N equals log of AR over P plus 1 all over the log of 1 plus R. So let's see, if P dollars is invested at the end of each year in an annuity earning annual interest at a rate R, the amount in the account will be A dollars after N years, and then we've got this formula. If $1,000 is invested each year, so P would be $1,000 in an annuity earning 7% annual interest. So R is 7% or 0.07. How long will it take for the account? And let's see, N is the unknown, to be worth $15,000. And let's see, A would be the total amount at the end. And it says write your answer to 1 decimal place. Okay, so what we've got is this formula, and we're going to put this information into it. So we're going to get N equals the log of, let's see, A is 15,000 times R, which is 0.07, all over P, which is 1,000, and then plus 1. Okay. And then in the denominator, log of 1 plus 0.07. Okay, I can plug this all into my calculator all at once, or I can simplify things along the way. It looks like the numbers would be kind of nice, so I think I'm going to simplify it. So if I take 15,000 times 0.07 divided by 1,000, I get 1.05 plus 1 would be 2.05. And then in the denominator, 1 plus 0.07 would be 1.07. So I'm going to take the log of 2.5 divided by the log of 1.7. Let's see what I get. Log of 2.05 divided by the log of 1.07. And I get 10.609. It said round to 1 decimal place. So with the 6, the 0 would round down. So we're going to get 10.6 years. Any questions about that before we go on? Again, you don't want to approximate anything before the very end of the question. Okay. So next up, let's see here. We're going to go to this one, and it's 11.4, number 33. Okay. So we're still in 11.4. This is number 33. And again, if I do a problem with the same numbers, please let me know. It says, evaluate the logarithmic expression. The log base 1/2 of 1 over 32. Well, I don't know what that's equal to, so I'm going to just call it box for the sake of solving it. So now I have an equation, and if I change this logarithmic equation into exponential form, I'll get 1/2 to the box power equals 1/32. Okay, well, 1/32 is 1/2 to the, let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 1/32 becomes 1/2 to the 5th power. 1 is equal to 1 to the 5th power. So this is also equal to 1 to the 5th over 2 to the 5th. Okay, but that's equal to 1/2 to the 5th power. So if 1/2 to the box equals 1/2 to the 5th power, what does the box equal? 5. All righty. Any questions on that before we go on? Okay, let's see here. 4780. 11.4. Number 7. Okay, we're still in 11.4. This is somebody's problem number 7. Write the logarithmic equation as an exponential equation. We have log base 7 of the square root of 7 equals 1/2. So the base is 7. So we're going to have 7 to the 1/2 power equals the square root of 7, which is the same thing as 7 to the 1/2 power. So this is it written in exponential form. Questions about that one? All right. Number 9. Write the logarithmic equation as an exponential equation. We have n equals log base b of r sub 1. So the base is b, so this would be b to the n power equals r sub 1. Okay, any questions there? Next one up is number 40, and I'm going to show you the picture of this so you can see what we're talking about here. Common logarithms, so that would be log base 10, are used to measure the intensity of earthquakes. If R is the intensity of an earthquake on the Richter scale, A is the amplitude measured in micrometers of the ground motion, and P is the period, the time of one oscillation of the Earth's surface measured in seconds. Then R equals the log of A over P. If an earthquake with an amplitude of A equals 5,000 micrometers and a period of P equals 0.4 seconds, what is its measure on the Richter scale, round to the nearest tenth? All right, so what do we know? We know that A is 5,000 and P is 0.4 seconds. So if we put that into our formula, R equals the log of 5,000 divided by 0.4. Okay, so I've got the log of parentheses 5,000 divided by 0.4, close it up, and I get 4.09691, etc., etc. It says round to the nearest tenth. That would be here, the 9 would round up, so it would be 4.1 on the Richter scale. Any questions there? All right. Number 41, we did a problem 41 earlier. This one, same kind of problem, different numbers. And what it has to do with is an annuity investment. And we've got this formula N equals the log of A times R over P plus 1 all over the log of 1 plus R. And we're told that P is again $1,000. R is 9% or 0.09. And A, the final amount, is $10,000. And we are to find N. Okay, so N would be the log of, let's see, 10,000 times 0.09 all over 1,000 plus 1 all over the log of 1 plus 0.09. So again, I'm going to simplify. If I take 10,000 times 0.09 divided by 1,000, I get 0.9 plus 1, I get 1.9. And the bottom I get log of, let's see, is that right? Yes, I was thinking I was going to get the same number, but I don't. 1.09. So I've got the log of 1.9 divided by the log of 1.09. And I get 7.44, rounding to the nearest tenth. The 4 would round down, 7.4 years. One of the things you need to be careful of, entering this into the calculator. When I put in log, it gives me that. Then I'm going to put in that. I need to close it up before I divide it. Okay, don't do this, because then it's taking all of this and sucking it into that first log. So you've got to close it up. Okay, there's another set of questions finished. Now let's see here. I don't know which screen I'm showing, so I'm going to make sure I'm on that screen. And we are on 4770. There, 11.4. Okay. And starting with 36. Okay. This is number 36. It says, use a calculator to solve the equation. Round your answer to 4 decimal places. We have log of x equals 3.1751. Now, what is implied but is not written is that this is log base 10. So changing this equation into exponential form, we get 10 to the 3.1751 power equals x. So we go to our calculator, 10 raised to the 3.1751 power, and we get 1496.580217. Now, rounding, let's see here, rounding to the 4 decimal places, that would be right there. The 1 would round down, so we'd get 1496.5802 as our answer. Any questions about that problem? Okay. Number 37, same, pretty much exact same idea. We're going to take the log of x equals negative 0.2790 and solve for x. This is an implied log base 10. So 10 to the negative 0.2790 power equals x. And if I take that on my calculator, 10 raised to the negative 0.2790 power, I get 0.526017, rounding to 4 decimal places, the 0 rounds down, 0.5260. And there's 37. All right. Okay. 38 and 39 are pretty much the exact same questions. So I'm going to skip that one. If the person asking still has questions, get in touch with me. 40 and 41 are also the exact same one. So again, I'm going to just skip those and go on. If you need those done specifically, email me and I will accommodate you with that. All right, one more here. Let's see here. Okay. I think these might be some questions we haven't answered before. We'll take a look and see. Yeah, this is a little bit different. Okay, let's take a look here. So number 2, it says fill in the blank. Log of x equals log of what? Oh, log, I see. So log of x equals log base what of x. So what they're wanting you to do here, what this problem is about, is showing that you understand that when there's no base written, it's an implied 10. So that's what they want you to put in the blank, is a 10. Okay. Now, one more problem, number 5. It says write the logarithmic equation as an exponential equation. Log base 10 of 10 equals 1. So this would be 10 to the 1 power equals 10. Now, the person, let me show what they wrote here. They've got 10 equals 10. Technically, that isn't wrong, but if you're staying true to the form, in other words, this is true, that this is the same thing as that, but they're wanting you to show where everything goes in place, and that's why this is the answer that they're looking for, rather than, or excuse me, this is the answer they're looking for, this one here, rather than what you wrote there. Okay, all right. That takes care of all the questions. As I say, one of you, I didn't answer all of yours, but they were repeats of ones before. Please get in touch with me if you need me to go over more specific questions. And now we are going to go on to the next section, which, as I mentioned, is 11.5 part 1. Okay, so yesterday we talked about log base 10, common log that's used quite frequently. There's another base besides 10 that is used quite frequently as well, and that is the number e. Now, e looks like it's a variable, but it's not. It's kind of like pi. Pi is what, approximately 3.14159, and then it just keeps going, all right? E is approximately 2.71828, and then it just keeps going. So roughly, very roughly speaking, pi is a little more than 3. E is less than 3, 2.7-ish, all right? Now, where e comes into play is where you have something that is growing or decaying continuously. And what do I mean by that? Well, let's talk about the population of Yakima County, okay? I have no idea what the population is, but is this the way that it works? Starting on January 1st, all the way up to December 30th, nobody dies, nobody's born. Suddenly on December 31st, a whole bunch of babies are born and a whole bunch of people die, and then the population changes. Is that the way it works? No. If you look in the newspaper, there's people dying, or people being born almost every day. So it's a continuous process. So population growth or population decay is a continuous process. When it's a continuous process, that's where this number E becomes involved, okay? And so we're going to be looking at that. A couple of things about it. First of all, log base 10, we write as log, right? Well, log base E, since it's also used quite a bit, whenever there's something used quite a bit, mathematicians like to use a shortcut because they're lazy, efficient. Log base E is called natural log. Natural log. And so what they do for log base E, they use ln. I don't know why it's not NL. Maybe it's log de naturel or French or something. I don't know. But anyway, so not only do you need to know that log base 10 is log, but log base E is ln. However, if you go back to your calculator and you look on that left column, remember that the word or the button that said log had a second function of 10 to the x. Well, right below it, there should be a button that says ln as in natural log. And if you look at its second function, it's e to the x. So that should remind you that this is log base 10 and this is log base e. Okay, so that's a new thing that you need to know. And let's see. Oh, let's talk about graphing. Okay, and I'm not going to spend a lot of time on this, but we looked at graphing y equals 2 to the x. Okay, and we went through and we made a table. Okay, and let's see, this was 1/8, 1/4, 1/2, 1, 2, 4, and 8. Remember we did this the other day? Well, let's look at the graph of y equals e to the x. Actually, I'm not going to look at the graph. I'm just going to calculate some numbers. Okay, so I need e to the -3 power. How am I going to do that? Well, on that calculator, remember there's the ln button, and e to the x is the second function key. So with your calculator on, if you push the second function key and then e to the x, this should show up. Okay, second e to the x, and then I'm going to put a -3 in there, close it up with parentheses, and I get 0.0. I'm going to round it to the nearest hundredth. Okay, and then I'm going to go back and I'm going to make e to the -2 power. And that comes out to be approximately 0.14. And then e to the -1 power comes out to be 0.37. What's e to the 0 power? That's 1. What's e to the 1 power? Well, let's see. E to the 1 power should just be e, which is 2.718, so roughly 2.72. And then let's see here, e squared is 7.39. All of these I'm kind of rounding to the nearest hundredth because I'm not going to be able to graph it super accurately anyway. E cubed is 20.08. All right. Tell you what, I will go ahead and graph these two just to look at them. So let's see. Actually, if to do that, I'm going to need to save all of these numbers. Well, let's see here. What am I going to do? This is going to be tricky. Maybe what I'll do is I'll ask, did any of you write those numbers down? Nobody did. Okay. So
Wait, I did, Mr. Mayo.
you did?
Yeah.
Okay. So let's see. Let me just recopy this. -3, -2, -1, 0, 1, 2, 3. So when X was -3, what was Y?
0.05.
And -2?
0.14.
Thank you. -1?
0.37.
And 0?
1.
1? And 2?
2.72.
2?
39.
What's that?
7.39.
7.39, and then E was
Yeah.
what, 20 point something?
Mm-hmm.
Oh no, I think it was. Okay, so if we graph that, -3 is way down here. -2 is up a little higher. -1, we're a little bit more than a third, and then we're at 1. And when X is 1, Y is 2.7-ish. When X is 2, 7.39. It looks very much like Y equals 2 to the X, okay? It's going to climb a little bit higher, okay? It would be between Y equals 2 to the X and Y equals 3 to the X. So again, the big mystery, this isn't a variable. It's a little more than 2.7. Okay with that? All right. Let's go back to the other screen. So now we're back to the normal screen here. Okay. We had a formula, A equals P times 1 plus R over K to the KT power. And we use that for calculating compound interest that was compounded annually, semi-annually, quarterly, monthly. I can't hold up 12 fingers, et cetera, et cetera. Well, what if we have a situation where it's being compounded continuously? Well, then our formula looks like this. Do any of you use Pert shampoo? Anybody? I think it's still out there. So I call this the Pert formula. It's not P-E-R-T, it's P times E raised to the RT power. But still, this formula we use when something is increasing or decreasing continuously. See, continuously. Is that right? Trying to find, I think that's right. Anyway, yes, that's right. Okay, seems like a lot of U's in there. So now let's take a look at some examples using this formula. It says, find A using the formula A equals P e to the RT power, given the following values of P, R, and T. If P is 5,000, R is 8%, which means it's 0.08, and T is 20 years. So A equals 5,000 times E to the 0.08 times 20 years. So what I'm going to do first of all, well, I could punch this all into my calculator all at once, or I can take 0.08 times 20. Either way, I'm just going to do it as it is. So I'm going to take 5,000. Now, where am I going to get E on my calculator? That second function button of ln, natural log. So then I've got 0.08 times 20, and I get 24765.16212, and it says round to the nearest hundredth. So this is going to be 2, let's see, that's not right, 24, 765.16. Okay. Any questions about that? Let's take a look at another example. In this case, P is 15,895. R is negative 2%, so that would be negative 0.02, and T is 16 years. So if the interest rate or the rate of growth is negative, what's going to happen here? What do you think is going to happen to our 15,895? It's going to decay. It's going to become smaller times 16. So I've got 15,895, and then times e to the negative 0.02 times 16, and I get 11542.1389. The 3 is going to round up, so 11542.14. Okay, so notice that this one got smaller because that instead of it growing at a rate of 2%, it's decaying at a rate of 2%, or decreasing at a rate of 2%. Any questions on that? Okay, let's evaluate some expressions without using a calculator. So the natural log of e to the 5th power, what does that equal? All right. Well, we don't know what it equals yet, so let's say it's equal to box. Okay. Keep in mind that ln, natural log, is the same thing as log base e. So the part I've got circled above becomes the part I've got circled below. So I've got log base e of e to the 5th power equals box. Okay. But now we've got a logarithmic equation.
Hello.
Let's change it to an exponential equation. Question? Oh, okay. I thought I heard something there. So e to the box equals e to the 5th power. So what does the box equal? 5. So the natural log of e to the 5th is 5. All right. Let's take a look at another example. The natural log of 1 over e cubed. Well, that's equal to something we're just going to call a box. So now I've got log base e of 1 over e cubed equals box. Changing it to an exponential equation, e to the box power equals 1 over e cubed. But isn't 1 over e cubed e to the negative 3? So the box equals negative 3, because when the bases are the same, then the exponents are the same. Questions there? Okay, how about this one? The natural log of the 5th root of e. Well, that's equal to some unknown box. Natural log is log base e. So we've got log base e of the 5th root of e equals box. Changing it to exponential form, e to the box equals the 5th root of e. But isn't the 5th root of e e to the 1/5 power? So the box equals 1/5. Do you see how this is working? I know I'm going kind of fast here. Are we okay with this? Hello? Anyone? No one's there? You've all gone to sleep? Okay. How about, let's use our calculator and let's find the natural log of 0.675. And we're going to round it to 4 decimal places. So I'm just going to push the ln button, not the second function that's e to the x, but so it's going to go ln, natural log, parentheses, 0.675, close it up, and I get negative 0.39304. So going out 4 decimal places, we would get that. Okay. How about the natural log of negative 10? So natural log of negative 10. do that on your calculator and see what you get. I'm waiting. We got a standoff here. Anybody? Nobody's going to try it. Has everybody gone away?
I would have to go grab my calculator. I left it in the other room.
Nobody's got their calculator. Well, if we go back to what we talked about yesterday, you can't take a log of a negative number or of 0. So you're going to get something like domain error, or mine says non-real, and then it says quit. So this doesn't work. You can't take the log of a negative number. All right. Now, how about this? The natural log of x equals 2.6490. And it says, solve each equation, express all answers to 4 decimal places. Well, this is the same thing as log base e of x equals 2.6490. Okay, because ln, natural log, is log base e. This is an this is a logarithmic equation. Rewriting it as an exponential equation, we get that. So now, second e to the x, I've got e to the, and I'm going to put in 2.6490. And I get 14.13989, which is going to be 14.1399. All righty. And let's do one more of those. The natural log of x equals negative 0.28. So log base e of x equals negative 0.28. E to the negative 0.28 equals x. And let's see what we get for that. Negative 0.28, 0.7, whoops, 0.75578. So the 8 would round up, 0.7558. We get that. And there you have it. So that gets us through the first part of section 11.5. Tomorrow we'll come back and we'll wrap it up looking at some application problems. I'll be back at 1:15 for my office hour if you have any questions. Otherwise,